Welcome in part 5 of the basic parts. Like I mentioned before, they're all pretty similar to the CSWA guide, so just, remade in my own vision, so it's maybe adding some stuff, and we're going to go over the drawings in more detail and the parts in more detail. So this one's part 5. We're going to call this one part with the hole, kind of in reference to my teacher always telling us that's what we're going to build during class. He was always just like, oh, we're going to build a part with a hole. And it kind of always was, but, every part's a little different, as you've seen so far. So this is just our first circular cut hole in a part. Essentially used a lot for screw holes and, so many peg holes, dozens of different applications for making a circular hole within a part. So wildly useful. You'll see some different notation on things like this. There should be like a through all notation here to show that it's through all, but you'll often see a little asterisk that says like all hole cuts are through all, stuff like that. So be looking out for that. If the drawer doesn't tell you, I'm telling you now. So I didn't feel the need to put it in there, but I figured I would talk about the different ways it's shown. So you might see it here. You might see it over here somewhere. You might see it down here. And it'll talk about the depth of the holes and the cuts and all that. So be looking out for that. Good practice is you really don't want a lot of these lines like oversecting each other so it looks weird. So we can do something like that. It looks a little better, honestly. Not too much better. Okay, we'll live with that. All right, so main thing with this part is the origin point. Now we're showing 3 different origin points. It's not really 3 different origin points. It's just a 3D way of showing it. So if I put the origin point somewhere within the part, you might think that it's like on this line or something like that. So we're going to clearly show it where it is in 3D space on all the drawings. So clearly it's at the front, bottom, center of the part. No angled cuts, but definitely a more complicated part today. So let's bust this out. Part. Millimeters. And I believe sketching on the front plane for this one's going to work best because we saw that origin, if you imagine 3D space now, that like kind of long Z will be here. If we extrude it from the mid plane, that's my plan, so we're going to stick to that and we'll see where it goes. I believe this was in line with it. And we had like a little branch, and this, and this, and this. I think this was in line, so we can make that relation. And I think that was in line there. So let's check that. I think that works. It is in line. 30 and 20 minus 50. Okay. So let's start adding these dimensions. 50 by 100, 30 by 20. All right, let's do it. Said 30. Yep. And this one is, and we could do that relation, but we could also do this. Control click both of these. It's telling you the distance between. Let's make them collinear. And since this one has its dimension, it'll put this one in line. Cool. Now that's lined up. I don't remember the distance here. I don't. Let's double check it. 30. You can see at the bottom there. 30 and 30. Cool. Let's plug those in. And that actually should be here too as well. You can see that blue line. And now the only last blue line. Okay. Let's mid-plane extrude this. Perfect. I think it was about 50 wide. Yeah, that looks about right in relation. Let's double check. Yeah. Okay. So we have our extrusion, we have our part now in kind of 3D space, but we're missing some features. We're missing like this cut here, missing this cut here, missing this cut here, and that cut there. 4 cuts, I believe. So let's talk about busting them out one at a time. We can't make this circular cut until we make this circular cut. I mean, we could probably come from the back side and cut it up 20 and then cut that back, but that doesn't make sense to me. Let's cut this one in first, and then we'll cut the circle in next. So, best way to do that is probably off the front plane, rectangle tool from the corner, and I think, yeah, it was all in line, so let's say, yeah, 20 and 20, because it looked like a rectangle. And it wasn't all the way through, but it wasn't really halfway either, so we're going to go 30, because that's been a number we've been seeing. Let's double check all that, though. Yeah, 30. and 20 by 20. Cool. So the things are looking in relation. And now we can do this. Let's sketch on that front plane, and we can put a circle here, right in the center. We can just kind of estimate it. And it was a smaller circle. I'm going to guess 5 or so, if I remember right. Yeah, 5. And there's no relations to it, but it looks centered here. It really does. And it wouldn't make sense for them to offset it here. So what I would do with that is I wouldn't put relations. I would put it like this in case the part was ever changed. I'd click on this line, find that midpoint. It'll show up eventually. Control-click that point. Make those vertical. Because that way if this square ever changes, like say this was going to be screwed into a wall and they needed this square to be bigger and the circle was bigger, the circle would move with the square if we did it this way. And I can show you guys that in a second if you want. Horizontal. And that locks it in place in relation to everything there. Now let's extrude cut that hole all the way through. That works for me. Looks good. All right, now we're missing those other 2 cuts. This cut that takes out this top chunk and this cut that takes out that bottom chunk. For this one, I would think drawing on this would make more sense than drawing up here. And I'll show you why. If you're drawing here, right, if you sketch on top, you have nothing to reference your square to, right? You'd have to put all those measurements in. But if I remember from the image, yeah, it's in line with this. This cut looks to be in line with this part. So if you draw from the bottom, it would allow you to line your rectangle up with this formed line that we already have. So let's do that. And then it auto sets the distance at 30 because it already knows. So now we just need to figure out what the distance is of this. We'll put this smart dimension in now, but we don't know what it is. And then we'll also drag this one in here, but we don't know what it is yet. Cool. It fully defines it, but we're going to go over here and edit that in a second. 12.5 and 37.5. So actually, we're going to delete this measurement in there, and we'll put that in there, and we'll see what happens. Let's delete this. I'm going to come from here. 37.5, 12.5. That looks good. Yeah, and fully defined. And I bet you anything this is now 12.5. Yep, the distance between the blue line is 12.5. Okay, let's cut that out. We're just going to go up to next. We don't need all that extra there like we did with the circle. Cool. Last cut. And this one, like I mentioned, kind of, it can be done on either side because there's no real relation for that box that we're seeing that's cut through. Another rectangle tool. Let's just kind of put it out there like we did with the last one. I do believe it was mid-pointed, so we could select this midpoint on this line, right-click, select midpoint, select origin, and make them coincident. Cool. Now whatever we do to this box, that'll always be coincident to the midpoint. What does this box look like? 15 by 15, and it's 17.5 from the edge. That makes sense. It looks like a box. 15. And I like to kind of put my dimensions where it's shown in the drawing too. That way when you go back and forth and look at each of them, you kind of know exactly where to look. You know what I mean? You want it to be quick as possible for your eyes when you're in an exam. And I don't think we actually need this one. Yeah, because we coincided to that midpoint, we don't need that other dimension. So that might have been a mistake on my end as making that assumption, because you can make mistakes making assumptions like that. But it did work out for us because we saw that distance was 17.5. So it's extrude cut all the way through. And I believe we have our part. Let's put it in ISO to double check. Yeah, it looks good. Looks good. I think we're missing, though, the material. PE high density. Yeah, we're missing that. You can always type in here, PE high. And it's not film, it's just PE high density. Cool. All right, like we talked about the other ones, I will put the mass properties in the comments. Good practice is pause the video at the drawing, maybe hear me talk about it for a minute. Then go try to make it yourself. Check the comments for the mass properties. If you nailed it, move on. If you didn't watch the video, figure out your error. Cool. All right, we'll see you guys next time. Thanks.